Welcome everyone. Thank you so much for joining us at what sometimes seems like midnight on a Tuesday, but is only actually 7 o'clock for this presentation about what's been going on at Sagg Pond. So glad you could all join us. So just a couple housekeeping things, and then I'll turn it over to John. Please use the chat if you have questions. I am going to mute everybody. But if you also just want to verbally ask something, just use the hand raise thing at the bottom of your screen. And that's pretty much all I have to say. So thank you for joining, and John, take it away.
Okay, so I'm going to share my screen, hopefully, just to bring up the watershed. I just have to find it here. I'm actually going to go to this one here. Everyone see that? Everyone see that picture of the Sagg Pond watershed?
All good, John.
All right, great, good. Well, welcome everyone. For over 2 years now, the Trust has been working with residents within Sagg Pond watershed and partner organizations such as Stony Brook's Center for Clean Water Technology, the Goldberg Lab, and Cornell Cooperative Extension. And why? We really want to understand the degradation of the pond's water quality and the rise of hazardous blue-green algae. And the problem can really be boiled down to a very simple fact that there's an overabundance of nutrients in the pond, especially nitrogen and phosphorus. And where does this come from? Well, multiple sources, including fertilizers from farms and lawns, septic systems, even atmospheric deposition. And others, there are other places too, but those are the principal sources. How does it get into the pond? Well, it gets carried in through groundwater and also surface water runoff. And we'll be delving into both of those things as we go into the program tonight. And then the key is how do we stem the flow of these nutrients into the pond? Well, a variety of things. Improved lawn and farm management, upgraded septic systems, and something called permeable reactive barriers. And that is one of the principal topics that we'll be touching on tonight. And I just want to acknowledge that the reason we're able to have this conversation is because of all of you. You have made it possible to have this discussion because of your support of the necessary research to understand the problem and your support of the Trust's role in coordinating this effort. And by coordinating this effort, I mean also advocating for action within the Sagg Pond watershed. Because of you, we have been able to leverage $219,000 in public funds through the town's community preservation fund, their water quality improvement program. And that money helped fund in part Stony Brook's initial study of the pond and also Cornell Cooperative Extension's groundwater analysis. So those have been fully funded by all of you, and our work has also been funded by you. So what I'm going to do is I just want you to take a look here at this watershed for just a moment before we move to the presentations. So here you see Sagg Pond, and the watershed is pretty big. It's pretty substantial. I want to point out Poxabogue Pond up here, because we're going to talk about Poxabogue as well, because it is part of the Sagg Pond watershed. This is Sagg Swamp here in between Poxabogue and Sagg Pond. I guess I just want you to get a sense of how big. These are all properties in this watershed that contribute to the water quality of Sagg Pond. And this map, which you may see again, is really important because it shows the travel time and how, what happens in various properties, how long it takes for it to get to Sagg Pond. And it's just a 2-year period where you see this darker red, almost burgundy color here, even some up here around Poxabogue. That's 2 years, 0 to 2 years. That what goes in the ground ends up in the pond. And then this other area out here, the bright red, is 2 to 10 years. So it takes a little bit longer, but whatever goes into the ground there goes into Sagg Pond and Poxabogue Pond, by the way. I bring Poxabogue into this conversation because it is in this watershed, but Sagg Pond is also part of a larger system of ponds that go all the way up to Sag Harbor, and that's called the Long Pond Greenbelt. And I think hopefully Day Dayton will join us this evening. I think a couple of board members of the Friends of Long Pond Greenbelt will be joining us as well. But the Sag Pond is the last pond to the south of the Long Pond Greenbelt, and Poxabogue Pond is an integral part of the Sagg Pond watershed. So I just want to make clear the connection. So what happens up here in Poxabogue also has an influence on Sagg Pond. So I just want you to all recognize and understand the interconnections here and how broad and how impactful everyone is ultimately inside these various travel times. So I'm going to stop sharing right now, and I'm going to turn things over to Ron Paulson and Molly Graffam from Cornell Cooperative Extension to do a couple of things, to give us an update on the research they've been doing around potential sites for permeable reactive barriers that they've been doing and that you have helped fund. And also to talk a little bit about Poxabogue Pond and a possibility for us to do some additional research there. And that's going to be followed by Debbie Aller, who's a scientist also with Cornell Cooperative Extension, a soil scientist, who will talk to us about a potential demonstration project that we have our sights on that relate to a piece of farmland adjacent to Poxabogue Pond. That all, again, impacts the Sagg Pond as part of the watershed. So without further ado, Ron and Molly, it's...
Sure, I'm going to go ahead and share my screen. Okay, so hopefully everyone can see my first slide there. Thank you, John, for that introduction and for setting the stage for this presentation. So like John mentioned, we're going to be giving an update on the Sagg Pond work, which may be a little bit of an overview of what you have heard previously in our presentation in September, but we have a few updates as well. And then some proposed work at Poxabogue Pond. I'm going to cover a little bit of background and then provide the Sagg update. And Ron will jump in with the Poxabogue update and we'll cover lastly some of the next steps for all this work. So this is a very similar map to what John had just showed. I think maybe Matt said that this was, that the map that John showed was the USGS model. And I guess this is from the Suffolk County Subwatershed Plan. So what you're looking at here is the model output from the Subwatershed Wastewater Plan. And as John mentioned, there are different groundwater travel times, and most of the groundwater travel times in the subwatershed are really in the 0 to 2 and 2 to 10 year range, but there's also some areas in the 10 to 25 year range. So that's really relatively slow groundwater travel time. So this means that nitrogen and nutrients that were added to the groundwater 10 to 25 years ago in some areas are actually just entering the pond at this time. And it's important to remember that this, these nitrogen issues kind of were generated over decades, and it may take some time to fix these issues as well. But this is always a great map to start with because it provides some really important information about land use and groundwater travel times. And this type of model output is really important for looking at like larger picture things like ranking water bodies according to nitrogen inputs. And what we see our work as filling a different role, like once these model outputs are generated and water bodies have been identified as being needing remediation and being impaired, our work actually goes in a bit further, and we can ground truth the data. We can really take samples and really understand the local characteristics, and models simply can't control or have inputs on all of these environmental data. So our work is really ground truthing and getting site-specific data that's necessary to support the design and implementation of nitrogen remediation approaches, like John mentioned, such as permeable reactive barriers, but there's also techniques like bioextraction and living shorelines. So water bodies that have already been identified as impaired, our work then helps fill this role of providing a comprehensive pore water and groundwater survey to identify and rank more localized zones according to water quality conditions. And this will help so that funds for remediation can really provide maximum nitrogen reduction. So we're really trying to target areas that along the shoreline of impaired water bodies that really are the highest priority within the water body. So here we have a more zoomed in map of Sagg Pond, and most of our data looks like this. We have maps with our station locations shown in red dots, and we have our transects shown by the yellow dotted lines. So I just wanted to briefly remind you that we started a survey of pore water and groundwater back in April 2021, and it occurred through most of the spring and summer. We have these stations within each transect and additional shoreline stations between transects. So we ended up doing a total of 184 pore water stations and collected 122 samples. And we did a very comprehensive survey of the pond and also focused really heavily on the Smith Corner Preserve, which is owned by the trust. So here is, again, a brief overview of some of the data that we presented in our previous presentation, but we really found a range of nitrogen concentrations in the pore water. Along the Smith Corner Preserve, the nitrogen concentrations ranged from below detection to about 6 milligrams per liter. And then in other areas of the pond, we found up to a little over 12 milligrams of nitrogen per liter in the pore water. And in addition to collecting pore water samples, we also measured discharge rates of groundwater seepage. And we found that generally along the northwestern shoreline with some of the highest seepage rates. And we look at these two pieces of information, seepage rate and pore water nitrogen concentration, to calculate a nitrogen load to the surface water. So that's really what we're working on now, is going through all of our data that we collected and calculating nitrogen loading to the surface water. And then we will be able to rank areas and prioritize areas that have the highest nitrogen load to the surface water, so that again, we would prioritize those areas as needing to be tackled and remediated first. And ultimately, we see that all of this data can be incorporated into any existing repository of water quality information and just help build upon the ongoing research in the pond. So the main update that we have today, which is exciting news, is that we submitted a proposal to the Community Preservation Fund and submitted some of this data that I just showed you. And we asked the town of Southampton to help fund the site characterization work for the Smith Corner Preserve and some other properties where the trust is highly involved through easements. And the site characterization data would provide information necessary to help design and install a nitrogen remediation approach, such as a permeable reactive barrier. And we're happy to say that the town of Southampton decided to fund this work. And so we received the funding of 107,000, a little over 107,000, which was awarded to the trust. And this was a match of what the trust had already raised through private donations. So this is really a public-private partnership. And we're excited to continue this work so that we can hopefully install some remediations along the edge of residential and agricultural properties. So just to quickly go over what this will fund, we are again continuing the work to understand the groundwater seepage and the groundwater seepage at the Smith Pond Preserve and other relevant properties, collecting data to inform the really specific location for a remediation approach, and getting the data that's necessary to design a permeable reactive barrier or other nitrogen remediation technology if we decide that a PRB wouldn't be suitable. But we really think that these areas are going to be suitable based on what we know of the soil conditions and the nitrogen conditions so far. And then again, we'll be communicating the results throughout these next few phases of the work. And the next few phases include the design and installation, which we will be, I think, returning to the Community Preservation Fund to look for more funds on that, as well as private donations for that as well. So just quickly to recap what PRBs are, if you did not attend our last presentation, they've been used throughout the Midwest and Canada to treat agricultural and septic nitrogen plumes. They have been recently installed near impaired water bodies in Suffolk County and on Cape Cod, and specifically Cornell has been studying one that was installed to treat groundwater before it entered Shinnecock Bay, and that's doing really well. We've been monitoring that system in Hampton Bays for a little bit over a year now and are really excited about those results. So we see permeable reactive barriers as one innovative solution. It's kind of a tool in the toolbox to help treat nitrogen that's in groundwater, and it can help treat legacy nitrogen as well. And we are interested in these things because they're passive. They require very little energy input after installation. They have no above ground structures, and they exist, they rely on microbes that exist naturally in the soil. And by adding the wood chips and the other media to help promote conditions, this allows microbes to transform the nutrient form of nitrogen, which is ammonium and nitrate, into a harmless end product, which is nitrogen gas that makes up 80% of our atmosphere. So with that, I'd like to pass it on to Ron, who will continue the updates.
Thank you, Molly. John laid it out there pretty well. The overall scope of everything we're trying to do. I think the other thing I would just kind of reemphasize is that when, we look at these watershed maps, how comprehensive they are. I always like to think of those as the overall body. And everything and every portion of that is important to the surface water. And so even though our focus is at the shoreline, it doesn't minimize in any way the need to have a healthy body, despite whatever other ailments you might have. It all matters in the big picture. But what we do, if you could kind of perceive it as a triage, that we know we have issues in the main watershed, that everybody could do a little better with care, whether you're residential, agriculture, commercial, whatever. But until those things, come around and we get a little more aware of how we're all connected to this, which we are doing, it's encouraging someone like me who's been doing this for a long time, to see the tide literally changing. But what we've come on is that, what can we do now? It's not a hopeless problem. the PRB's research that's been going on recently, give us this triage, if you will, that we can get, if we can identify where the wound is, where the really bad spots are, we can implement some of these remedial measures and start to reduce stress on the surface. So that's really one way of looking at it. As you would look at your own body, you have overall needs and health, and you also have others, maybe more specific needs. But anyhow, so one thing interesting about Poxabogue is it's kind of looks isolated from the overall watershed and Sagg Pond. But all of these things are connected through groundwater. Groundwater is always flowing, to a lower level or lower energy. So even though Poxabogue is up there, it looks isolated, but it's not. And a lot of the things we want to do, what we're proposing is to understand how that fits in the watershed and the different aspects of that. As we did find in Sagg, we found areas that have high groundwater discharge, a lot of nutrients coming in. And we found other areas, southern parts, that actually recharged, that the water in the surface water was entering back into the ground. And Poxabogue Pond, like most ponds, have these areas. They have areas where the gradients and such push water in and contribute what's in the groundwater to them. And then they have areas that are lower heads that actually recharge and then go back into the groundwater. And in this case, then they travel down to Sagg Pond. So that's why they're all connected. Watershed is one. And even though Poxabogue looks isolated, it's not, it's connected hydraulically to the whole system. And how we go about doing and understanding that, obviously the modeling has been useful. It tells you these are kind of basic principles of hydrogeology with these ponds and around. But you really need to, as Molly said, to ground truth and really understand, how these ponds are related to the overall watershed. So the ground truthing that we're proposing is very necessary. Flip to the next one, Molly. So how do you do that? How do you go and look at an area like this to find out what zones, what areas are important as far as groundwater discharge, what nutrients are entering the pond, and what other areas, although important, maybe are not so much receiving groundwater, but groundwater is actually discharging on those shorelines. Not to minimize the need to be conscious of what happens at the shoreline. And I guess one of the properties to the east there that Debbie Aller is going to talk about is kind of in the middle. We don't really know that, that property is directly influencing Poxabogue or not, but we know it's in the watershed and ultimately will continue downgrading, and we'll have some effect on the watershed overall. But basically, how we do that is we try to do these transects for water like we did in Sagg across the pond. Excuse me. We also use the seepage equipment that gives us a discharge rate of that groundwater coming through the box. And then, as Molly said, we can use that to quantification of a nutrient level. And then we can prioritize what areas of the pond are important to look at, what can be done inland, or what can be done with PRB or with a living shoreline. And so that's really what our goal is, to understand, as we have good understanding now of Sagg, what's going on in Poxabogue, to help the overall decision-making process concerning land. So the tools we've been using, if you're not so familiar, are these probe systems that we've been developing for a long time. And they actually are probes that are inserted into the bottom that measure a variety of things. Most important for determining where submarine groundwater discharge is there's usually a contrast between what's in the surface water temperature and conductivity and what's in the pore water, which is usually more representative of groundwater because it is groundwater. And so we use those to map out these areas. And the probe was designed to do that, and it's very effective in doing that. And we make these measurements pretty routinely, about a foot into the bottom. And, we determine where groundwater discharge is, and then we can move in later with the seepage meters and then collect the nutrient analysis. In this case, mostly nitrogen and phosphorus. But there's other things we collect to verify that, other parameters. And the discharge rate, the equipment we use is very precise. It's uses ultrasonic technology. And actually it can measure, you can see it over on the left, and has a funnel that gets inserted on the bottom, into the bottom. It's on the bottom. You can't really see it here, but it's a collection funnel. And everything you see on top is the computer, the battery, the flow tubes that measure ultrasonically. But it's so sensitive that if you can imagine a drip growing on your faucet, it can measure that. That's the sensitivity you need, and it took a while to figure all this out, but it's very useful because we can get these nutrient loads calculations that are hard to do with a model, because everything is variable and site specific in these bottles. So the objectives are, as I've stated, are really to use this equipment to quantify where the nutrient flux is, characterize overall what's the fate of the groundwater as it enters the pond, travels through the pond, and then we suspect on the downgradient side is actually re-entering into the groundwater system and traveling further. And all of that is just continuing to build on our ongoing research in this watershed, and then to use all of this obviously to educate everybody, ourselves obviously, and provide some recommendations and hopefully some remedies to help this Poxabogue, as we hope to bring some relief to Sagg. So we've prepared a plan and budgets and such, and we hope to, we've presented those to John and the Land Trust and to all you folks, in hope that over the winter we can discuss that, and then if an agreement is reached, we could start that in the spring and carry it through next year. And by the fall, have a similar output as we have with Sagg. Start to look at next steps.
So,
that I'm going to pass back to Molly.
Yeah, just to finish us off here. Some of the next steps, like I mentioned earlier, is to really compile and analyze the Sagg data. We've gotten We've got so much data to go through over the winter and really compile that and identify and rank the areas where there's significant nitrogen load to the pond. And then because we've received this grant, to continue work through receiving the CPF funds, we're going to continue to do site characterization work, specifically at the Smith Corner Preserve, and then possibly some other properties where there is a high nitrogen load to the surface water, and possibly begin the Poxabogue survey if that's something that is going to happen in the next year or so. And we also have some, while we are very interested in doing the field work and, really doing the site characterization for the PRB work, we also have some more applied research ideas and lab work that we're interested in. But we're always thinking of ways to improve upon the permeable reactive barrier technology by making it either more efficient at removing nutrients or less expensive or easier to install. So we currently are very excited about this technique called the column array. So there's a kind of a schematic of it in the bottom left-hand corner of the slide, but basically this column array could potentially be installed using a geoprobe, which is actually a much less expensive type of equipment than the traditional equipment used to install a PRB trench. And along with the agricultural program, Cornell recently secured a geoprobe, and that effort to secure the equipment was largely led by Debbie Aller, who you'll hear from in a few moments. But we have this geoprobe now, and we'll be receiving it within the next month or so. And so this will give us the flexibility to do a lot more applied research and think about best configurations for a column array. And we think this is going to be less expensive and require possibly like less material, less media, and will be easier to install. So we're really excited about that technique. And then we're also interested in doing some bench scale work, looking at the inclusion of biochar or other amendments that can help with phosphorus absorption in addition to nitrogen removal, and looking at particular ratios of the media, such as the wood chip to biochar ratio, to come up with like the best, most efficient recipe for the PRB media. And there's also some tests that would be really helpful to do on the hydraulic conductivity contrast. This is like how easily water can flow through the media, the PRB media, compared to the native soils. So really, there's a lot of research topics to really help refine and make the technology even better. And so in some cases, there's a lack of grant opportunities to look at this type of work, but it's a really important research because ultimately we're interested in refining it and making it more effective and more cost effective. So with that, I'd just like to quickly go over a few takeaways. Again, land use, chemical makeup of the groundwater is so important for local surface water quality. And we see our work as helping to ground truth model data and really prioritize shoreline areas that have high nutrient load. And this will help guarantee that funding for remediation is spent most efficiently. And PRBs are one tool in the toolbox to tackle the nutrient problem, and they require site characterization for determining the design. So they require a lot of work up front, but then they are a passive approach that requires minimal maintenance for decades. And then some other nitrogen remediation techniques that are also really promising are, of course, living shorelines and bioextraction. And there's many necessary measures needed for reducing excess nitrogen in our groundwaters and surface waters, including updating septics and improved fertilization practices. We just see PRBs as a tool that can be used as like a stopgap measure while all these other things are being implemented. And with that, I'd just like to thank everyone on behalf of me and Ron for listening to our part of the presentation, and I'd like to pass it off to Debbie Aller.
Awesome. Thank you, Molly and Ron. Really great presentation. You guys have done a tremendous amount of work collecting data to really show what is happening and tell more of the story with the pond and why there are currently water quality issues and will continue to be. So there we go. Hopefully I'm in presentation mode and everyone can hear me. I don't think this group has heard me talk before, so I'll just mention, as John previously introduced me, I'm Deborah Aller. I'm with Cornell Cooperative Extension in the agricultural program, and my background is a soil scientist. So I focus a lot of our efforts with our ag community on soil health and soil management and what we can do to adopt and implement practices that will build soil health. And I will tell you all in this brief presentation what I mean by soil health and what are some of the practices that we can start to think about for, encouraging farmers across the East End to implement, and what can potentially be done at this Poxabogue demonstration site. And I don't know if, John, you wanted to say any more about kind of the background about the demonstration site, or we'll just refer questions to you at the end when it comes to, I guess, kind of any relationship with the town or anything like that. Okay, we'll leave that for the end. So really, this idea about potentially a demonstration farm or some type of ag parcel at this one property adjacent to the Poxabogue Pond, it would be a collaborative effort between the Trust, Cooperative Extension, the town, because it's currently town-owned property, and the Friends of the Long Pond Greenbelt. And it's really starting to focus at the idea that we must heal the land and take care of the land to protect our water. Because we all know that water and soil and the land are connected. And so that's why Cooperative Extension Marine Program, Molly, Ron, and then myself with the Ag program, we're working together, because we can't think about water quality, agriculture, and land use without connecting those. They're really an interconnected areas. So as you saw within the maps that Ron and Molly presented, and this is just a zoom in closer to Poxabogue Pond and then kind of orienting you all in this red box here, the ag parcel that we're talking about, or potentially demonstration site parcel that we're referring to. So this box isn't a perfect outline of the property, but essentially you can see this ag field up through this forested area and down. So you can see how close it is to Poxabogue Farm, or Poxabogue Pond, sorry. And hopefully a lot of the work that Molly and Ron are doing will tell us where is the groundwater flow underneath this land. And so really what we're talking about with a demonstration site is this idea of soil health. And this is not a new concept within the ag community, but it's something that really hasn't been emphasized until relatively recently, and it's been gaining a lot of traction. And a lot more farmers are adopting practices that not just sustains the soil and the health of farms, but it actually builds the quality of the soil and improves it to get greater crop productivity, reduce runoff and erosion, and other factors that we know have an impact on ground and surface waters. So in soils, there are largely three areas, three properties of soil: the physical, chemical, and biological properties. And normally when farmers are fertilizing their fields, they're thinking about the chemical properties. They're looking to change the pH of the soils. They're looking to add nutrients like nitrogen and phosphorus and things like that. But soil health really makes that connection that we can't view a single property of the soil in isolation, that all the properties are connected. So it sits at this integration of the physical, being the structure of the soil, which I'll talk about in a minute, the chemical, like the pH and the nutrients and all the fertilizers that needs to be added to the soil, And then the biology. We know soil is a living system that needs to be fed in order to be productive for us. So a couple months or about a month and a half ago, I just kind of went to this area on the road to see what this property looked like currently. And these are just a couple of pictures from me standing on the road. So Poxabogue Pond is behind me to the west, and we're facing east in these images. And so I'm sure, many of you have probably driven by here recently, but this just gives you some general idea of the current status of this parcel. On the northern end here, let me just grab the laser. On the top left here, it's forested. Kind of this western area is really inundated with mugwort, ragweed, and other weeds. And then the main body of the parcel is being managed by a local farmer and cutting hay off of it annually, just to give you some idea. But can we start to think about this parcel being used more productively and in a way that will improve the health of the soil and not impact the quality of the pond and affect the surrounding community? And so the main idea behind this possible demonstration site at Poxabogue Pond is to highlight practices that offer a holistic approach to land management that provide an opportunity for community education. So it being an open potential demonstration site would generate income and support a local farmer. So provide economic, financial support and for the community as well, and environmental protection. So not negatively impacting the quality of the pond and the larger Sagg Pond watershed. And so the idea behind this was kind of twofold on when we look at this parcel. And one is this idea of a vegetative buffer. So this is essentially putting a permanent living perennial annual planting on one part of the parcel that would reduce erosion and run off into Poxabogue Pond. This picture on the bottom left it's not from Long Island, but it gives you an idea of what I'm referring to when I say a vegetative barrier. And here it's simply a grass strip. So leaving some type of grass or planted area between a farm field and a water body. So obviously we have similar conditions here on Long Island where we have farms and properties directly adjacent to water bodies. And this goes for, lawns and private properties as well. And the second aspect of this demonstration site would be implementing regenerative agricultural practices. And the idea with regenerative agriculture is really at the foundational level. It's all about building soil health. So not sustaining it, but improving it by adding organic matter. And it encourages continuous innovation. So growers, can they adopt new practices like reducing tillage and planting cover crops, which are a couple of the pictures I have here on the bottom. And the whole idea behind regenerative agriculture is that it's not only improving the land, but it directly provides greater crop production with fewer inputs to the land. So those are the two kind of overarching ideas behind this demonstration site. And now I'm just going to kind of provide some of the justification for thinking about these possible ideas here. And it gets back to the soil. And so here I've pulled a soil map from the USDA, which is the United States Department of Agriculture, and this web soil survey, which is an online tool where you can get the most recent soil survey data for any parcel. And it's updated annually at this point. It used to be a hardcover book, but now it's online, which makes it a lot easier to access. So I collected a soil map of this parcel, so you can see it outlined here. We're going to ignore this forested area because I'm going to say this multiple times. The forested area would remain forested. Nothing would be changed there. But what I want you to notice here is this PLA and this BG, let's say BGA and B. And those indicate two different types of soil. PLA is a Plymouth soil and then a Bridgehampton soil. So these are soil types. They have different properties, and how you think about managing soils on a farm will differ. The second A and B we have here are just related to the slope. As you saw in the initial pictures, it's a relatively flat piece of land. And the overall size of the parcel is about 8 acres. With the area in the Plymouth sand a little bit under 1.5, and then the one in the Bridgehampton loam being about 6 acres or so, subtracting out the forest. So just going to get into a little more detail there because we're talking about soils and their suitabilities, essentially. How suitable are they for a given function, whether it be constructing a home or supporting agriculture production. So on the top left here, not to get into the nitty gritty, but this is simply known as the soil textural triangle. And it gives us some idea about what are the proportions of sand, silt, and clay in soil. So what makes soil coarser, like let's say a sandy beach, versus a finer soil like a Bridgehampton loam or something like a muddier, finer, darker soil. So the first one is a Bridgehampton loamy coarse sand as the soil map classified. So this is about that western 2 acres of the parcel closer to the pond. And so this is a sandier soil, coarser textured. So looking at a loamy sand, that means it has more than 70% sand and it has a very small amount of clay. So its ability to retain water and nutrients and build organic matter is lower than what we'll say is the Bridgehampton silt loam, which is the other soil at this parcel. So when we're thinking about this demonstration farm and recommendations for possible use, the idea with the Plymouth sand would be to keep it in a permanent living cover, because we know the coarser soils, the nutrients leach more readily from these soils, and their ability to support crop production with without more inputs is decreased. And so that other part of that parcel, that about 5 acres on the eastern side, is a Bridgehampton silt loam. And I know many folks on the South Fork are very familiar with Bridgehampton soils, and I know our farmers are in particular, because these are some of the most productive agricultural soils in the US, and particularly on the East End. They're rich, loamy soils. They have more favorable properties when it comes to retaining water and nutrients, allowing roots to grow, building organic matter, making nutrients available to plants. I could go on and I won't, but these are more of a medium textured soils that are very favorable for crop production. So breaking this parcel down, thinking about it and possible uses, when we think about those soils and the purposes of this site, and thinking about the proximity of the pond over here on the left to this parcel, the idea would be to leave the forested land in permanent planted as a forest, and this area, which falls within those Plymouth sandy soils, in a permanent living vegetative buffer, which supports both annuals and perennials. It would be a habitat for pollinators and other wildlife in the area. It would help with reducing just the presence of mugwort, ragweed, and other weeds currently present within the site. It would help control erosion. When we think about perennials and annuals in the landscape, the depth of roots, the structures of roots is very different, and their ability to capture water and nutrients differs within the soil profile. And then by keeping this in permanent living cover, if we think about the bigger picture, we're aiding in carbon capture and potentially climate mitigation to some extent. And then on this eastern side in the orange box here roughly would be this ag demonstration farm, which would highlight regenerative ag practices. And what I'm going to just put here are a few examples of what we mean by, or what I mean by regenerative ag practices. And just a couple pictures from farms here on the East End that are already implementing regenerative agriculture. And when we think about planting cover crops, and this not just cover crops over the winter, as many people are familiar with seeing, like planting a rye cover crop, but using practices where we're actually integrating and interseeding cover crops within the actual growing cash crop. In this case, our fall brassica crops like cabbage and broccoli and Brussels sprouts and things like that. Can we, on this site, use reduced tillage or conservation tillage? So not going in there with a plow, something folks are very familiar with seeing, but using more reduced tillage practices that protect the soil and reduce erosion. And then rotating crops. We all know very diversified operations on the East End. Many farms are already planting over 100 varieties of crops. So is this something that could be implemented at this site? Utilizing integrated pest management, or IPM. This is a practice where we know if we're monitoring pests and diseases, we can reduce the need for external inputs. And then adding soil amendments like compost and mulch and wood chips, or leaf material, as you can see on this picture here on the right. And so as Ron mentioned, I just have a couple slides left about monitoring. It's important to monitor changes over time. So anything that's done on the land does not end up in our water. And so these are just a few bullets mentioning some of the strategies that could be done at this site. So we can, guarantee or provide real data that what would be happening at this property would not be affecting the pond. The groundwater monitoring wells, these would be deeper, much deeper wells on the parcel. There are simple lysimeters, and here's a picture just on the right of a lysimeter or soil water sampler, and you simply auger out a small hole and install these into the property, and then you can collect the leachate and see what would be running through the soil. We would recommend or require some type of soil nutrient testing on an annual basis. So a farmer who would ever be working the parcel know what nutrients are in the soil and on that property at a given time, and determine what the optimum amount of fertilizer a plant would need, so they're not over applying or under applying fertilizer. And then this soil health testing, and this is something done on about 4 or 5 year basis. So these are just a couple of examples of how the property could be monitored to ensure it's functioning in a regenerative way. And so I'm just going to leave you with a couple pictures when we think about soil management, and particularly a parcel like this, where the idea is implementing regenerative practices, is that the two pictures here are both soils on Long Island, on 2 different farms on Long Island, and how they are managed is distinctly different. And I think it's hopefully obvious to see which soil is functioning better, and how the soil is managed and how a property would work as a demonstration site will have a direct impact on water quality. But if it's focused on improving and maintaining healthy soil, we can maintain clean water and not have issues with water quality in Poxabogue Pond there. So I will leave it at that, and happy to answer any questions, or if anyone has other ideas or comments on kind of what I shared tonight. My email address is there. And with that, I will stop sharing and I guess open it up for questions.
So we can unmute ourselves if we want to ask a question, as I understand it. So feel free if you want to ask a question. You've got an opportunity, and so we'll give you a minute to see. In the meantime, I'll just say that this particular project, we are basically negotiating with the town on the use of this property. It's owned by the town, was purchased using Community Preservation Fund money. And we think that this is a win-win for everyone to have a program like this, where we are demonstrating how to prevent surface water from going into a Sagg Pond or Poxabogue Pond, and the use of native varieties, native plants to do that, which could be used by, as I think Debbie mentioned, by property owners on the pond, anywhere on Sagg Pond, as well as on Poxabogue Pond. And then because agriculture is a contributing factor to nutrient loading in the pond, to actually demonstrate some regenerative techniques that potentially other farmers could use on their properties that abut Sagg Pond, for example. So I think it's a great opportunity. We don't have a complete buy-in by the town at this stage, but I think we're making progress with that. And look forward to, again, having an opportunity to give everyone practical solutions to apply to their own properties, whether it's a vegetative barrier or property management for a farmer, that can be useful in mitigating the nutrients that are getting into the pond, which is really the source of the problem. Do we have any questions? I see something in the chat there. I don't know what that is.
No, it doesn't look like there is anything so far, John.
Okay, well, this has been recorded, obviously, and we're gonna share this with everyone on our email list. I just, in closing, I again want to thank those of you who have contributed to the trust and to the research that has been done both by Stony Brook and by Cornell Cooperative Extension. This is all about having a real understanding of the dynamics of the pond, and then taking steps to improve the water quality. So we know from what Ron and Molly said that they are finishing up their site characterization study. As we look at the new year, we expect to hear from them a proposal as to the location of a PRB or a variation on the theme using the newest technology, again, to see how we can affect and really prevent the flow of nitrogen, at least in one site. That becomes a model for other sites on Sagg Pond. So we're really building the technology and really showing how, as a community of people in this watershed, we can take action to improve the water quality. The other piece of this puzzle, we are also negotiating with Chris Gobler and the Center for Clean Water Technology to come up with a program to assist property owners in the watershed, especially those in the shortest travel time to the pond, how to upgrade their septic systems and access the public funds that are available to subsidize the cost of that, but also to figure out what the best system is for the conditions of that particular property. And so that's something that we hope to shine a light on in the first quarter of 2022. As well as the potential installation of a PRB also in the pond. Now, all of this is going to cost money to do, and we've been very successful to date in leveraging private money to get public money to support these efforts. That will continue. In order for us to actually start work on some of the things we've already discussed tonight, just the looking at Poxabogue Pond and a demonstration project. What our goal is going to be, and we'll announce this to everyone in the watershed, is to raise $150,000 by the end of January. And that would be to fund 50% of the Cornell Cooperative Extension work on Poxabogue Pond, and we would go to the town to try to get the rest of that. We don't have a budget yet for the demonstration project. We want to pull as much out of the town as we possibly can, but assume another 50 for that, and then 50 to help again underwrite the costs of the trust to spearhead and manage this process of really making Sagg Pond a healthier and cleaner water body, and something that we've been doing for the last 2 years, again, with your support. And we want to continue that in that role, and hope you'll help us out in that regard. So more to come. Obviously, anyone that has missed this that that lives in the watershed, please encourage them to contact us so they can, if they're not on our email list, we want them, so they can get the updates and be invited to these sessions as we go into the new year. It's going to take all of us to make this happen. And again, I really want to thank you all for your support. And I want to thank our presenters tonight and our staff that's here to make it happen. And I wish everyone the very best during this holiday season. Please stay safe and be well. And we'll be in touch again very soon in the new year.